Good morning, mathematicians. Welcome. Me saying things weirdly like that is the price you gotta pay for listening to me say other weird things. You know what it is. It's Spectral Sequence time. Part 7 already. Getting close to the double digits. And getting close to chapter 2 where we start, where things get real, presumably, because they haven't been real yet. Okay. I think we were somewhere here. We were right around the definition of the vertical action. Vertical is appropriate because it acts on elements, moving them up. If we had a filtered graded vector space, then a gamma module is filtration preserving if it preserves the filtration. Yeah. Crazy. If we descend to the associated bi-graded vector space, then that should act vertically on there. For a graded algebra to act on a spectral sequence, we require that, of course, it acts on every page, that the differentials are module homomorphisms, and that the gamma star action on the next page is induced from the previous page. So, suppose that H star is a gamma module. In applications, we want to determine H star as a gamma module. That is to compute H star along with its gamma action. And, of course, we say it converges. If it converges, blah, 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 filtrations. Yeah. Oh, got to turn on live chat. So, okay. Man, I've been so tired in the mornings lately. It's just fall is like that, I guess. Gotta get some coffee in here. Gotta get my brain working. So we have a spectral sequence, converging, filtration induces the action, bi-graded space, isomorphic. So here we come to theorem 3. There is a spectral sequence on which gamma acts with the E2 page being something computable with a known gamma action and converging to H star. In the next example, we present a situation which is maybe a little artificial, where the gamma action plays an important role. In natural examples, arguments similar to the one presented here can be employed with remarkable success. Go read Sayre, he says. Don't believe me? Oh yeah, you don't believe me? You don't believe me? Go read Sayre. Huh? We'll see if you believe me then. Wow, no one's in chat. I didn't start this early. I didn't start that early, did I? No one's yapping in chat yet. Okay, so we got Q adjoin two variables. We'll give them degrees 2 and 5. And we're going to suppose we have a spectral sequence with E2 being a module. And we're going to suppose that E2 has module generators. Gamma's that thing. Okay, and we suppose that E2 has module generators given by that with some bi degrees. And gamma acts freely on this basis? Well, what does that mean? Freely on the basis? Huh? What does it mean to act freely on a basis? What is A times X? What does it mean for a module to act freely on a basis? Oh, yeah. Okay, sorry. Yes, of course. Oh my god. It's just a free module. Right. Somehow I was thinking it should be Q coefficient, so I was like, how are A and B supposed to be acting? No, it's coefficients in the ring. It's coefficients in the ring. Is chat not working? It's so weird that no one said anything yet. So I'm going to try and pop it out again. It says 5 people watching. Don't be afraid to say hi. The government's not watching, or maybe they are. Keeping track of who knows spectral sequences. It's true, deep, forbidden knowledge. And they need to know who knows. Well, thanks for saying hi. Hello. Okay, glad to see that chat is working. Hi, chat. Hello, Matthew Mathica. Okay, now that I know I'm not alone in this world, I've got at least 4 of you with me here. Okay, so we're saying that it acts freely on the basis, except we're going to say that B kills X. Okay. Under these conditions, the spectral sequence collapses at the E2 term. Collapses before it even gets going. First, observe that the differentials commute with the gamma star action. They do? What are the differentials? What? That's just by definition, right? Because we're assuming... yeah, we haven't even said what the differentials are. Am I crazy? We have generators, by degree, X freely on the basis. So how can we observe that the differentials... Oh, is it maybe... Is there something in the bi degree that tells us this? Oh, I guess something in the bi degree would tell us this, right? Because, so if X is in bi degree 8, 4, okay, maybe I should write some things down. Oh, give me a second here. I gotta adjust my screens and stuff. Yeah, I guess this has something to do with the bi degrees that everything lives in. And probably from that, we can compute that and that it acts freely on the basis elements. So the bi degree of X is 8, 4. The bi degree of Y is 6, 0. And the bi degree of Z is 0, 4. Right. And then what did we say before? How is the differential supposed to change the bi degree? We had some condition on that. Might have to look it up in the book. Might have to look it up in the book. I'm curious, some of the commenters who said hi today that maybe don't usually say hi. I'm curious to know if you've been following along the whole time, and if you're like learning spectral sequences alongside, or you just like putting on listening to someone yap about math in the background, or what. Spectral sequence of algebras. Right, bi-graded. Okay, here we go. So D... Holy moly. Okay. Yeah, what were the conditions we had here? I guess we want the second thing I said, like hearing someone yap about math in the background. Well, I'm glad to be providing that service for you. Okay, so has to satisfy the Leibniz rule. We want the differential bi-graded algebra. So with a total degree 1 mapping. Total degree 1 mapping. But don't I want this to be... hello, Onage effects. I got it right this time. I don't know why. Every time I stared at it, my brain was just like, oh, you have to read this word again, and we're going to struggle to read it. I don't know why. You got your ass kicked by the Sarah Spectral Sequence, and now you're out for revenge. In your algebraic topology class. So this is interesting to watch. Good. We will have your revenge, Yoshi Star. We will have your revenge. The book I told you about is so good. Hell yeah. Hell yeah. You swear it might be the second best book. Oh, what is the first book? What is the first best book? I'm curious as to what you think is ahead. Well, what am I doing wrong here? Where's the bi degree? Where's the bi degree? Oh, I guess. Wait a second. I'm crazy. So, right. I guess the point is, right. So X lives in E284. Is that right? And so the differential. Of X should live in E10. E10 minus 2 plus 1, 3. Right? So how do I make a 10 here? So is that's 0. Right? Because I don't think I can make a 10 out of these bi degrees. Am I totally misunderstanding here? Differential Geometry of Curves and Surfaces by Manfredo P. Ducarmo. Yeah. Okay. I've actually never spent serious time with that book, so. But certainly many people have given it high praise. Yeah. Okay, am I just out to lunch here? Okay, where were we in the actual reading now? Yeah, let's look at this example again. What's going on here? Well, in this case, we supposed certain things, but Okay. Let's go back to the actual question. This is so awesome. Me being confused on live stream. You would enjoy that. Okay, so observe that you'll spend the rest of your week learning algebraic topology. So you're not going to do your representation theory homework? Bro, you just read the first page of a Luffy and you're already mesmerized. No glaze though. Well, no, put all the glaze you can on my man Luffy. That I'm with you there, but Luffy's one of my favorite books, so it's a great book. Great book. Just wait till you get into it. I mean, it's a fun book. It's a fun read. Right. So the differentials commute with the action. Sure, that's just because it's some free action. It suffices to show that this is true on all basis elements. Aha. Okay. Nice. And I think by what I just said, maybe this is part of the proof that d2x is 0, because if I'm right, then there's nothing with the appropriate degree. The generator Z survives to E infinity since it has total degree 4, and in total degree 5, this is E2 is trivial. What? Any differential originating on Z lands in total degree 5, and so is 0. Wait, so how does it survive? How does it survive? Hello, Pajama Man. This implies that Y also survives to E infinity. No multiple of Z hits Y, and Y cannot bound any other element. So we are proving that each differential survives to the E infinity page. Okay, now I'm confused. We should go back to the previous example, because somehow surviving tells us the collapsing. On the way to Copenhagen, doing baby homological algebra. Hell yeah. Well, clearly you're doing big boy homological algebra right now by being in the stream. So there's that. Okay, let's go back and review this example. What was going on in this example? So first, observe, we only need to know the action of differentials on the generators. Yes, because Leibniz tells us everything else. With the given information, we can list the entire E2 term of the spectral sequence in the diagram. Yes. Okay, so I think we had placed these things here just based on where their bi degrees were. And I see. And I guess it's surviving. Hello, Fimno. And I guess the surviving to the term is basically, whoa, didn't mean to do that. Although, never bad thing to end up on archive. And I guess surviving to the term is because like ERPQ is like the kernel over the image. Right. So if we could argue that the image was 0 and the kernel was everything, then that is it surviving. You don't know why you hate applied math. You just like abstract stuff. Yeah, I wouldn't say I hate applied math, but yeah, I've also quite clearly partial to the abstraction myself. You could say I'm something of a man of abstraction myself. So okay. So then if x is in by degree 8-4 on the E2 page, let's consider a map going into there. So that would be coming from so if we had E2 8 4, this would be coming from E6 E6 5, right? Because it'd be 5 minus 2 plus 1. You think that is just a fundamentally wrong understanding of applied math? What? What is a wrong understanding? Ownage FX just stated their opinion. How's that you don't do it, but it doesn't just mean you look for your problems in other fields and abstract from there? Huh? What? Doesn't it just mean you look for your problems in other fields and abstract from them? No, not necessarily. I mean, there's a lot of applied math that looks a hell of a lot like pure math. Because, of course, this is not a well-defined boundary. But then there's also just math that's very, very applied, you know? Saying it's not as abstract as pure math. I mean, yeah, so of course, if you try and zoom in on the vague boundary between these topics, that disappears. But on the whole, it is just less abstract. It is just less abstract because you're trying to solve a tangible real-world problem. I mean, you may consider, a 64-dimensional state space or something that are like of some particles moving or whatever, but I would pound for pound, it's less abstract for sure. I would say that. Doesn't mean it can't ever get abstract, but okay. So let's see. Could we cook up an element that lives in degree 6-5? No, that's impossible. Just looking at these by degrees here. So, right, that means that that's the 0 map. I see. Okay, so then that means that, hello, Zarzarland. There's no distinction anymore. You really think there never was, just snooty people. Yeah, well, if I can't be snooty, how else am I supposed to feel good about myself and superior to everyone else? Exterior algebra. Wait, we haven't been here yet. Where are we? I'm lost. Okay, here we are. We're at our example. If Leray didn't study PDEs, we wouldn't even have spectral sequences. I mean, this is true. Well, I don't know. Because maybe someone would have invented them eventually. There is this article called You Could Have Invented Spectral Sequences, which is actually where I got the name for my video, You Could Have Invented Semi-Direct Products. Although I don't know if I'm convinced by the article. Like, there's some things in math that just seem so inevitable that's like someone would have invented them eventually. From where I currently sit in my understanding of spectral sequences, I don't have the same feeling that this would have been inevitable. But yeah, who knows? Who knows? It's possible they'd exist. But I don't feel in my gut that they're inevitable yet. Okay, so we checked it on one basis element, so it must be true for all the basis elements, right? Oh, wait a second. I made an oopsie though, because he says the element X, however, could be mapped to AW by D2. Wait, is that true? Wait, is that true? Wait, X lives in... X has by degree 8.4, right? X has by degree 8.4. So if we apply D2 to it, it should have by degree... the differential of X. Oh, I missed the by degree of W. Ah, that's what it was. Okay, I forgot about W. Okay, so the by degree of W is 10.1. Right. So, right. So, right. And now we can see if we add up these degrees, this could be ZW, I think. No. Right. Hang on. He says it could be A times W. He says it could be A times W. Oh, and then, wait, do I also need to account for the shifting of degrees? So, hang on, if X, right. So wait, if W is in, well, what am I doing? Right, how do the elements affect the total degree? So, W is in E10.1. And the degree of A is 2. So then AW has to live in where? AW has to live where? You just have to lock yourself up, then it becomes inevitable, sure. But you can say this about anything that somebody accomplished. Guy invents X, one might say somebody would have invented X anyways. Yeah, but you could. I mean, okay, and like if we assume for practical purposes, observable universe, finite volume, so much stuff, you could, I don't know, make some argument about everything being inevitable or whatever. But I think there's things that this is more true for than others. I think there's things that people would agree, right? Like the invention of the number 0, right? I think that's a lot more inevitable than the invention of spectral sequences. Like, if we visited if we found some other alien civilization, I would say that I'd be much. I mean, okay, maybe this isn't a good example because like you need to invent the number 0 before you invent spectral sequences. But I think there's some things that are just like much more inevitable than others, right? Like, I don't know, like music is a weird thing, and instruments, like I wouldn't expect other civilizations to invent the piano, right? But I would expect other civilizations to invent the wheel, for example. Um and so certainly, yeah, like, and probably there was no one person that invented the wheel, right? Like, that's probably something that came up numerous times across civilizations in human history. You have the linear algebra book by Spence. I've never heard of it. Do you need background in calculus for it? No, you definitely don't need background in calculus for linear algebra. Of course, your life becomes meaningful when you combine linear algebra and calculus. That's what gives your life meaning. Spectral sequences. You wonder how they are relevant to Galois cohomology. Well, very relevant, because Galois cohomology is cohomology, and spectral sequences allow you to compute cohomology. They help you compute. It's a tool for computing the cohomology of stuff. Yeah. Hello, ABCD. You guess so. Look up Hawkshield Serre spectral sequence. Has to do with group cohomology. Yes, and then therefore Galois cohomology. Changing your mind. Young Sheldon was right about the number 0. Do not mention that disgusting show on my channel. Marina Viazovska's sphere packing stuff just came out of nowhere. And you guess nobody knows how she came up with this genius stuff. Is that true, though? I mean, I'm sure she's given talks. Maybe she's given talks. But maybe she shouldn't explain her thought process in the talks. I don't know. Yeah, actually, fun fact, I think she is at the place in Sweden that I applied to. I think she's at the place in Sweden that I applied to, but I don't know. Are spectral sequences in any way related to spectral analysis? Not really. Different uses of the word spectral. Of course, you could try to cook up some way in which they're related, but no. Did I learn formal logic from writing proofs? Sort of, yeah. I've never taken a separate course on formal logic. No, that show's awful. I hate it. And I hate the Big Bang Theory as well. Have you ever seen that diagram? Where's that diagram? No offense here, but yeah, I think is this the one? No, there's one. I think this is it. I think this is the diagram. Yeah. Here's the diagram. For about smart people, for smart people, Rick and Morty. About smart people for dumb people, Big Bang Theory. About dumb people for smart people, It's Always Sunny in Philadelphia. And for dumb people, about dumb people, Friends. So there we go. Shots are being fired. Call the police, call the military. Shots are being fired at the Big Bang Theory. Yeah. Topological operators are very interesting stuff. I haven't really studied them in any depth, to be honest. Didn't she just write down some modular form and prove that it works, and didn't really motivate why she wrote it down? I mean, maybe in the actual paper. But could be, I'm saying, She might have given talks and explained her thought process in those talks. And maybe later papers have come out with collaborators. So I don't know. I've not been following it closely, but yeah, maybe the original paper might have just been, blindsided everyone. You want to hear my thoughts about free will? I don't know. It's confusing. I mean, we'll never not feel like we have free will, and we're going to behave like we have free will anyways. So, it doesn't really matter. But everything we know scientifically about the universe suggests that free will doesn't exist. Or if it does exist, at the most, it's very limited. That's if I'm putting on my scientific rational hat. But then, I don't know, maybe there's weird spiritual oogly boogly stuff going on behind the veil of reality. But I don't know. So, yeah, that's it. That's it. Okay, so we're assuming this acts vertically. Right. So then AW lives in E10-2. Is that correct? And is that where I found the image? But I thought X lived in E10-3. Okay. Maybe the idea is just incoherent and many people mistaken it for something else. Yeah, I mean, there's a whole question about whether the concept of free will is like even coherent or not, but yeah. Okay, yeah. So gamma S of E and T is in E N S plus T. So let's go back and redo this computation here. So X is in E284. Did I get the formula right? So D2 of X is in E2. We add the degree here, and then minus 2 plus 1, that's in 3. That's in 10-3. I'm sure I did that part correct. Okay. Meanwhile, W is in E2 10-1. Oh, yes. And then A has by degree 2, so AW is in E2 10-3. Right. Okay. Awesome. I'm a genius. It took me, 40 minutes to understand this extremely simple example, and I made a bunch of computational mistakes. But regardless of that fact, I'm a genius. What can I say? Sarah sequences are related to vibrations, from what you know. That is also my vague understanding. You mainly work in bundle theory now, so when we see the hop vibration, I think we have here a classic case of Sarah sequence. Yes. And hopefully we will be able to go through that computation in the series at some point together. Okay. Now we've checked it. Now we've checked the claim on a single element, and therefore it is true on all the elements without having to do any other work. Okay, so Z survives. All of these survive. Notice this could be hit by this. Okay, I'm having gone through on the computations in detail. I'm happy to just accept the rest. Right. So he says X could be mapped to AW D2, but since BX is 0, we can compute this. B comes out in front. We have BAW non-zero. Sure. Okay. I see. So this should be this is the infinity page, or this is the E2 page? I mean, we're saying that it collapses to E2. That's the argument, right? Wait, so D2 AW leads to a contradiction? Wait, why? Why? What's the contradiction here? Wait, what's the contradiction here? So, since BX is 0. Oh, BX is 0. Wait, why is right, BX is 0 because of the pi degree that it lives in. Okay. Additional literature, if ever needed. Algebraic topology, Lefschetz. I mean, he's a goat, but really, I feel like that book's got to be so old now. Is there any non-disgusting typeset version of it? Fiber bundles by Hussmoller. Man, I've looked at one of his books once. It was way too crazy for me at the time that I looked at it. Oh, kind of old. You prefer Lefschetz to Hatcher? All right. That seems strange to me, but I haven't looked at Lefschetz, so I can't say anything. Do I have any advice on how to get comfortable with abelian categories? Yeah, find a book about them and do exercises. Yeah, I don't know. Well, prove that some categories are abelian categories. I mean, what are the category of abelian groups? Is the first one you should do. Go prove that's an abelian category. What else should you prove is an abelian category? The category of modules. And actually, if you do that, then you get the category of abelian groups for free, because that's equivalent to the category of Z modules. Maybe in a couple of weeks I will return to my categories of module series, where I was showing where what I need to do next is to show how if you have a category with biproducts, you can actually get a unique abelian, or not quite abelian, but you get a unique additive category, and that's part of the structure of the category of biproducts. So that I will be talking about maybe eventually in my categories of module series. Special K, how do you know my street name? How come a functor from an abelian group to a ring forms a polynomial ring? What? So I don't know what you mean by that. I mean, an abelian group can be realized as a category with a single object. And we can take a functor out of that, I guess. I guess maybe you could do the same thing with a ring, but I don't know how that forms a polynomial ring. I have no idea what you're talking about, to be honest. Are you talking about the fact that the category of representations of G is equivalent to the category of modules over the ring of functions on G? That's the only thing I could think that maybe you're talking about. How do you stop hating Landau notation? I don't know, because I don't know what that is. And weird asymptotic stuff in analytic number theory. I don't know. I ignore that. That's what I do, is I just ignore it. An interesting fact about abelian categories is you don't need to add the structure of an abelian group to Hom sets. Yes. Yep. Maybe you just came in. Maybe you missed that part, but I was just talking about that. I think that's the next thing I'm going to, when and if I get back to that series, I will be explaining that in more detail. Maybe even I started explaining that in the first video. I don't remember, or in the second video. Okay, it's been like 10 minutes. I haven't done any spectral sequence reading. You meant the category of abelian groups and the category of rings? Yeah, I still don't know what you mean. So a functor... So what are you saying? A functor from the category of abelian groups to the category of rings forms a polynomial ring? This is news to me. Functor from abelian groups to rings. Do you mean the image of any group has to be a polynomial ring? Yeah, thanks AI. Thanks for telling me that. Yeah, I don't know. I'll be honest. I don't know. I don't know what you're referring to here, Onush. If you can maybe give me a reference or something to go look at that discusses this thing you have in mind. Okay, theorem 4. There is a spectral sequence of algebras with this. There is a spectral sequence of algebras with this as bigraded. What? What a weird non-constructive theorem. There is a spectral sequence that looks like this? Cool. If H star is a graded algebra, then we can cook up a spectral sequence defined by tensor products that converges to it. I mean, that's a little crazy. That's seemingly crazy. Do you mean the forgetful functor from commutative rings to abelian groups has an adjoint? Oh, the free ring functor. The free ring functor. Yeah, so is that that's this. That's this guy, right? So you send a group to well, let's say a finite group, say over to the ring of functions over the field, right? This is a set of functions under the convolution product. So f times g at x is just the sum over all h and g of fh gh inverse x. So that's what it does. That's what it does to objects. And then on morphisms, so if you have a homomorphism of groups, let's see, I think you get a homomorphism. I mean, I claim that this has a basis, this ring has a basis given by indicator functions. So this is the function that is 1 when x is equal to g and 0 otherwise. And so you can just define the map. You just define the map going this way, where tilde here is just equal to the indicator function of 5g. And there you go. So I told you what it does on objects. I told you what it does on morphisms. Now, your homework is to prove that this is a functor. But that's what it is. At some point, you found a paper that gave Fa di Bruno formulae for polynomial category affairs. I have no idea what that is, Nadia. But it sounds interesting. Polynomial category affairs. I'm not sure what that is, or Fa di Bruno formulae. You love seeing math people studying together? Oh, hell yeah. That's what we're all about here. Indicator function is your favorite function. Yeah. They're good functions. They're functions that I believe in. Okay. I think we're gonna wrap up stream soon. I felt like doing, it's Friday. Felt like we should have a nice long one. Slow start to the day. I gotta record my next group cohomology video so it can come out for noon. Oh yeah, YouTube won't let you link things, except for Rod, who isn't here today. I gave him special permission. So where are we here? If H star is an algebraic invariant of a topological space, we can think of V and W as similar invariants. Wow. To rush ahead to chapter 5 for a moment. Oh, here we go. Vibrations, baby. Oh, Cockett. Oh, did you know he's actually I'm at his institution. I lately haven't been going on Fridays, which is today. There's category theory meeting, seminar, talks type thing. And so normally I often see him there on Fridays when I go. I haven't been going to very often recently. But when do I start stream? I don't know. It is never set in stone. Generally of late, I don't know if you can see times on my previous streams that I started, but lately I'm definitely not starting any earlier than 8. Well, I certainly have started as early as 6:30, but 8 mountain daylight time, which is about to change. I don't know when daylight savings is, but yeah. Normally around 8, maybe closer to 8:30, between 8:30 and 9 is pretty typical, but that's, the peak of the bell curve, and then the distribution goes off to infinity on either end. Never made it to any of those? Well, maybe you should have. Mountain time isn't real. Try one of the real ones. It's real to me. It's real to me as someone living in mountain time. MDT, baby. Was it GMT minus 6 or GMT plus 6? I don't know. One of those things. Okay, I just want to finish up this paragraph and get the hell out of here. 1726 MEZ time. What is MEZ time? Not sure what that is in North American time zones. I am not sure either. MEZ. Mountain Eastern Z? Or no, I mean, those are probably Z because it's a word in another language. German, maybe? German's got lots of Z's. MEZ is GMT plus 2. I see. Yeah, maybe what am I? MDT? Maybe I'm GMC minus 6 or something. MDT time. Yeah. 2 GMT. Right. 6 hours ahead. GMT is 6 hours ahead. Yeah. When I get back, or when you get back, you think you will be expected for your undergrad thesis? Oh, to go to the meetings? Maybe. Ah, you're in Berlin. Okay, I called it. Ah, Zeit. Of course, right. Of course, Zeit. I should have guessed. I mean, I was close. I picked up on the German Z vibes. Yeah. Mitteleuropasch. Pesch. Yeah, meine Deutsche S. Nicht gut. Okay, I gotta finish this paragraph and get out of here, gang. To rush ahead for chapter 5, a moment, H star, maybe the K-valued cohomology of E. V will be that, W will be that, where we have a vibration. Nice. Suppose that H is known as well as V or W. Wait. Isn't the whole point of the spectral sequence to figure out H if we don't know it? Does a spectral sequence have enough structure as an algebraic object to allow us to obtain W and V star? To obtain W... Oh, to obtain W when V star is known or vice versa. Oh, and we suppose H star is known. Ah, interesting. That is, can we work backward from the answer and part of the data to the rest of the data? Interesting. Nice. I see, Leo lectures. I see. Yes. Before presenting some examples of the situation, we introduce an algebraic condition on our graded algebras that is characteristic of the topological invariance. A graded thing is skew commutative if we got this thing right. Over the field of rational numbers, free graded commutative algebras come in two varieties. We've got this generator. Since parts of that are all in even dimension, they commute with each other, and so that is, there's a polynomial algebra on one generator of dimension 2n. Suppose that B star has one generator of odd degree. Since we have that, we deduce that, so any higher power of that is 0. We denote B star by that, the exterior algebra on one generator. I see. Aha. Now we're getting the cool stuff. Okay, so tomorrow we will do example 1H. It's basically like a long exact sequence. Trust. I do. There are enough borrowed German words and German names in math. Yeah, that's true. Such as Zentrum, which is why the center of a group is denoted with a Z. That it helps to pick up the pronunciation scheme. Which is extremely regular. French too, though it's not as regular. I did used to... Apparently, when I was a young child, growing up with my German-speaking grandparents, apparently I spoke German pretty decently for a young child, and then I completely forgot it. And then, like 5 years ago, I went through a phase where I started learning some German on like Duolingo and watching some German TV. Shout out to a Dark, hell of a show. Shout out to Babylon Berlin, another hell of a show. Love them. But obviously my German is not kept up since then. Anywho, that's going to do it for today. Tomorrow, example 1H. And until then,